We're going to graph all of the trig functions in this section, and let's start with the most common first one, y equals sine of theta. Now notice this graph I have changed a little bit, so instead of 1, 2, 3, 4, 5 in the x-axis, I have pi over 2, pi, 3 pi over 2, in other words the radian measurements. Now if you think about what they are, since pi is 3.14, that means 3 is about here, this is about 1.5, so we actually have about 1, 2, and 3, which we could put on here if we wanted, or you could use a regular one and mark where pi over 2 and pi and so on are. But we're going to use this, and we'll be able to set it this way in the graphing calculator if we wish, without those, but at least the tick marks would be in the right place. This paper and other ones to come also have a table of values set up for trig functions in particular, where we're going to use the radian measurements now, but we could also instead be saying 90 degrees, 180 degrees, 270 degrees, and 360 degrees, and of course 0 is the same as 0 degrees. And I could have done that here also. There wasn't anything stopping me from calling this 90 and 180 and 270 and 360 and so on. But I both like using this, and everyone needs to get used to it, so it'd be good for you to see it now, and you'll get used to it on this in this video at least. So what we're going to do is to find out where sine is at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And that'll be one period, and then we'll just repeat it for the other one. So I've set it up here for what is probably one period. So what we need to do is find the sine of 0. And the sine of 0, using the unit circle, is simply the y value at 0. So that means the sine of 0 is 0. And the sine at pi over 2, or 90 degrees, is 1. And the sine at pi, so again we're going to be at 0 here. So we're just going around to pi, 0, and then negative 1 for 3 pi over 2, and then we'll be back around at the beginning. So we'll be at 0, negative 1, and then since 2 pi and 0 are the same, it turns out in this case that it starts repeating there. When we graph it, we're going to do graphing just like normal. So when the y is 0, or when the x is 0, we're at 0, then the x is at 0, we're at 0 for the y. When the x is pi over 2, we're at 1. So let's get this so we can see as much as we can of both of it. Pi over 2 is at 1. At pi, we're at 0. At 3 pi over 2, we're at negative 1. At 2 pi, we're at 0. And so this is approximately what it looks like, taking into account, of course, that I have a hard time drawing a thing called a curve. Now, that's one from 0 to 2 pi is one period. On most of my test questions for graphing, I require 2 periods. Therefore, you need to continue it. So since 0 and 2 pi were essentially the same, so are 5 pi and 2. So we'll go up here to about where 1 is, and 3 pi. So if I added 2 pi to this, 2 pi to this, 2 pi to this, and 2 pi to this, we would be able to get our second, it was the second period. And it would be going on and on. Now, notice something. I attempted to make a curve. There are good curves. They're not great curves, I admit, but they're curves and they're an attempt at a curve. So be careful, because if you have something, let's do almost the same kind of thing here. If you just want to connect the dots, then you're going to lose points, because it's not a connect the dots straight lines. It is not straight lines. So do not give me straight lines. You must at least attempt to curve. If your curve's not very good, or if you end up having to redo it and cross some out, I don't care. Just make the attempt. If I think you didn't make the attempt, you're going to lose credit. All right? And you have to convince me. You can't tell me, well, I thought it was a curve. I'm going to say, I didn't, and I'm the one you have to convince. Okay, so this is what a sine curves look like. As you do things with in details in physics with sound, the sine curve is actually the curve that's used to model sound waves. So it comes in very, very handy in physics. Let's take a look at cosine. We're going to do the same kind of thing, but now we're going to be looking at cosine theta. So I'm going to use the same kind of graph. I'm going to come down here and we're going to look at cosine 0. And then cosine pi over 2 and so on. And that means the unit circle. And cosine at 0 is 1. Cosine at pi over 2 is 0. Cosine at pi is negative 1. At 3 pi over 2 we're at 0 again. And then did I get something mixed up here? No, I don't think I did. 0, 1, 0, 1, and then of course it's back to 1. Yeah, no, it looks like I'm okay. So now we're going to graph these on here. Cosine at 0, when the angle is 0, we're at 1. When the angle is pi over 2, we're at 0. Pi, we're at negative 1. 3 pi over 2, we're at 0. And at 2 pi, we're back to 1. So the curve looks like this. It's not as satisfying a looking curve as we're used to seeing with the sine curve, but it is indeed the sine, the cosine one. But we can now repeat it just like that, and then it will look a little more satisfying. In fact, some people might realize that it's actually the same as the sine curve. The sine curve was like this and then continued. It's the cosine curve is the sine curve just moved over a little bit. Now this is a good time to look at these in the graphing calculator. Okay, so let's graph first the sine and then the cosine curve. And I'm going to put my sine here. So on the sine one, press y equals. Oh, first, something to go back to. Okay, oops, let's clear off here. And the first thing to know is that you have to change for the mode. Go on down here to radians and go over. See where it says radians and degrees? When you're graphing trigonometry, you have to do radians. All the trig functions have to be in radians. So there, I just changed it to radians. Enter, press enter, and then clear, and you're out of it. Now, when we graph it, I'm going to put sine x. Theta can be done, but it's a real pain to do, so you might as well just do x because the calculator sees it as the same. When I do graph, well, there it is, but it really doesn't look as similar enough to what we do. So I also want you changing the window when you're doing this, and let's make that negative 1. The x minimum to negative 1, the x maximum to 7, because that'll be, since 2 pi is 6.28, that'll be a little bit past it. And for the scale, we're not going to use 1. Use second function and pi, second function and the hat symbol to get pi, and put divided in 2. That's 90 degrees. So we'll go at pi over 2, and then at every pi over 2, it'll put a tick mark. So pi over 2, then 2 pi over 2 is pi, and 3 pi over 2, and 4 pi over 2 is 2 pi, and so on and so on. Now let's look at the y's. Oh, look at what it did. It changed it immediately to the decimal. So 1.5708 is something you can write in as well if you'd like to. Just round it correctly and carefully, and round it as far as possible. So going out to the 6, making the 9 a 0 or 8, that's definitely an 8 there, but don't round it just 5.7, you lose too much. Go 5.708. Better if you just do pi over 2 and let it figure it out. And then for the y minimum, I'm going to do negative 4, and then already had this one at 4 for that one, and the scale will stay 1. So there is the sine curve. If I had not changed the mode, let's go to that, then the graph would have looked like this. You can tell from that little thing moving there that's still working. You see something coming up there, but doesn't really, you don't see much. That's because it's not in the right mode. So we change it back, and it makes for a nice sine curve. And the cosine curve would do the same. If you just change it to cosine, you get the what the cosine curve looked like. So I think they look reasonably similar. All right, let's go on now to our next one. We're going to look at when we change them. First, a different amplitude. The amplitude is basically how far up or down it's going from the center of it. So what we're going to do is do 4 sine theta, and I'm going to come down here and do this. So what this is going to be, I think we're going to use area down here, sine 4 of 0. Okay. Oh, no, I had that wrong. It's 4 sine 0. So that was a mistake on how I wrote it. Very important not to do a mistake like that. Be careful, because this one changes the period, this one changes the amplitude. Well, we know from the sine graph before that the sine of 0, and plus from the unit circle, the sine of 0 is 0, so that's 4 times 0, which is still 0. And then we're going to do 4 sine pi over 2. Well, 4 sine pi over 2 is 4 times 1, so it's going to be a 4. 4 sine pi is going to be 4. Well, sine of pi is 0. So it's 0 again. And then I'm going to do 4 sine 3 pi over 2. And that's going to be 4. Sine at 3 pi over 2 is negative 1, so that's going to be a negative 1. And then 4 sine 2 pi is like 0. Oops, I put negative 1, and I'm absolutely good. This is an easy one to fix, to write negative 4. Okay, now let's come on up here and let's graph these. So 0, 0. Let's get this so hopefully we can see most of them. Pi over 2, we're up to 4. At pi, we're back to 0, and 3 pi over 2 is at negative 4, and 2 pi is 0. So we're going way up, coming way down. Let me back up, and then of course it repeats. So I'm going to do the same thing to get a second period in there. Whoa! So that amplitude really stretches out that way, or it would compress it in. If that had been 1/4 sine pi, we'd be going instead of at 1, we'd be at a quarter. And it would look, this would be at a quarter, that would be at a quarter, and it would look like that, instead of the normal one, which is out to here. Down to negative 1 and up. So basically now you get the idea. This one looks more like about a half or a third, but I think you got the idea. And you see how this can make a difference and help with sine and cosine and tangent and then cotangent. It helps. It doesn't with cosecant and secant, but we'll be dealing with those later on. Okay, so now let's look at one where it's the period that changes. All right, so we're going to look at cosine 1/2 theta. So come down here, that's going to be cosine 1/2 of 0. Now that's an interesting one to consider. That's not something that you've seen much or thought about. It will actually make it very easy. It's just going to be 1/2 of 0. So that's cosine of 0. Oh, I meant theta. The cosine at 0, we just revert to whatever that 1/2 makes it. So cosine at 0 is 1. So when I do cosine of pi over 2, well now, here's the interesting thing. Let's say, notice something. I could do pi over 2, and then that's pi over 4, and that works. This is a very good place to think of it in terms of degrees instead of radians. So I'm going to do that right now for all of these others. Okay. And so cosine of 1/2 of 90 is the cosine at 45. Cosine at 45 is square root of 2 over 2. And square root of 2 over 2, when you put in the calculator, it's 0.71. Well, when you're trying to hand graph, if it was 0.75, okay, I'd leave it there. But 0.7 is definitely good enough for like trying to hand graph it. So it's a good way to approximate it there. So when we do cosine 1/2 of pi. Well, that's cosine pi over 2. And the cosine of pi over 2, 90 degrees, well, actually, we'll always revert back to this. Cosine at 90 is, we're going to pi over 2. The cosine at 90 is 0. Oh, so we're at 0 here. So it looks like we're going 1.70. I'm guessing that's going to go down to a negative. So cosine of 1/2. So I had done, let's see, 180. That made 90. This would be 270. Half of 270 is 135. So the cosine at 135 is negative root 2 over 2. Root 2 over 2 is 0.7. That's going to be negative 0.7. And then the cosine of 1/2 of 360 is the cosine of 180. So the cosine at 180 is negative 1. Okay, now let's graph this. 0 and 1. 0.7. So at pi over 2 we're at 0.7, which is right about here. At pi we're at 0. At 3 pi over 2 we're at negative 0.7. So if this is at negative 1, I've got to come up a little. And then 2 pi is at 0. Now this is an interesting curve. We can't even continue it here. We don't have, like, if this was one period, we'd have to jump up to here. Well, we're not going to do that. In fact, the point of this is that the 1/2 stretches it out. So instead of the period being 2 pi, the period is now 4 pi, which means we have to do more of these. So what I'm going to do here is I'm going to extend this. Okay, I'm going to say after 360, the next, in fact, think about what happens here. We go from 2 pi, well, we keep on going, so I'm going to go 360 plus 90 is 450. And then 360 plus 90 is 450, plus another 90 is 540, plus another 90 would be 630. It's nice and easy to add 90, add 90, add 90. And then another 90 would be 720 degrees, which would be 360, or at where 360 is. Actually, here, though, we have to do the 1/2. So cosine 1/2 of 450. Let's write that a little bit more neatly. Cosine 1/2 of 450. So 1/2 of 450 is 225. Cosine of 225 is over here. That's negative root 2 over 2, which we know is like that, negative 0.7. Negative root 2 over 2. Then for 540, cosine of 1/2 of 540, okay, that's going to be the cosine of 270 degrees. And the cosine at 270 is 0. So I'm not going to graph the rest of this yet. Right now I'll stick with finishing the table of values. Now I have some room here to do cosine of 630, 1/2 of 630. So that's what, 315. So that's a cosine of 315 degrees. 315 degrees, the cosine is a positive root 2 over 2, which is 0.7, positive now. I'm guessing that 720 will be back to where 1 is, okay, but we can do it. Cosine 1/2 of 720 is 360, and the cosine at 360 is indeed 1. Now let's graph this. Okay, 450 or 5 pi over 2. 5 pi over 2 is negative 0.7, which would be down to about here. At 540 or 3 pi we're at 0, and then we're at 0.7 here, and then at 1 here. So it's tempting to go up like this to get to the 0. That's why putting the point here and forcing yourself to go to the right spot makes a difference for getting the graph correct. So this is actually like the, where it is, page 2, I can't find it yet, but this is really like the cosine of theta was. The original cosine actually had us down to here. So this is what cosine x is. And when it's cosine 1/2 x, that stretches it out because of what it does to the numbers down here, 1/2 of each of them, as you saw. All right, so if it had been cosine of 2, it would have taken this and pushed it in together, and it would have been here and then again. So it would have been a much shorter one.